Day three of my NEET Code 150 challenge, and we are tackling one of the OG problem, uh, LEET Code 1 to some problem. So here's the setup. You are given an array of integers, okay, and a target value. Your mission is to find two numbers that add up to the target. Easy, right? Let's see if you are faster than the hash map. Okay, example one, you have 2, 7, 11, and 15. Okay, the target value is 9. The output is 0, comma 1. How did you get the 0, comma 1? Because the array is 2, 7, 11, and 15. Okay, if you want the target 9, he said to add 0th and first index. So what's the 0th index here? 0, 1, 2, 3. 2 and 7, which is 9. This is how you got this output. In the similar way, this is also same. 4 plus 2 is 6. This is 0, this is 1, and this is 2. 1, 2. 4 plus 6 is 6. 4 plus 2 is 6. Okay? So this problem is basically Tinder for numbers. Okay, so we have two numbers and you're trying to find the perfect pair that makes 9 or 6, this is just like Tinder. Okay. All right. Let's start with the brute force approach here. You'll take every number and try matching it with each other number. Okay. Like testing every possible couple at the party to see who adds up right. For 3, 2, 4, target is 6. Okay, so we'll see 3 plus 2, which is 5. No, 3 plus 4, which is 7. No, 2 plus 4, 6. Boom, it works. But it is painfully very slow. It is taking like big O of n square complexity. What if you have 1,000 numbers and that's a million checks? Like if you have so many number of numbers, and you're gonna check million number of times. By that time, your interview will be over. Okay. Now let's act smart. We'll use a hash map, which is nothing but hash table. Basically, a little brain that remembers what you have seen. We'll walk through this whole array now, okay? For every number, you calculate what you need. The complement. See, basically, the target value is 6. We have to add something with this 3 to get 6, right? That can be 3. So we know that what to add, you get 6, which is nothing but 3. Okay? This is nothing but complement value. Okay, but we don't have 3 over here, so we will check 2. 2 with something. What's that something? You'll get 6, which is 4, which is here. Okay, this is nothing but complement value. So to get this, what you will do, this is the target value, this is the number from array, this is the complement. What you will do, complement is equals to target minus the number. Target, what's the target? 4 is the target. What's the number? What's the number? 2, which is nothing but 2. This is how you calculate the complement. That's why complement is needed. Okay, I'll address this. Since it's a small problem, since it's a small problem, it is not that difficult. What if you have thousands of numbers? You can't use the previous method. Okay, Now, then you check, hey, have I seen that number before? If yes, boom, you got a pair. No, note this number down into this hash table. Let's see the problem now. Take the number 3. So, how much you need into 3 to get 6, which is 3? Okay? Can you see two other, can you see 3 other than this 3 in the array? No, right? So you will write this number 3 and what's the index of this number, which is 0. Okay? Okay, now let's take the number 2. So we need 4 to get 6 as target. But we don't have 4 in our hash table. In the earlier as well, the table was empty. So we have added this 3 into our hash table. So we need 4, which is not found in the hash table. So we will add this 2, which is a number 2, and its index has 1. Okay, we have the number 4. How much do we need now? We need 2. Okay, we need 2. Do we have 2 in this hash table? Yes, we have. Boom, you got your pair here. Okay, that's one pass, which is big O of n time. Okay, space complexity of is big O of n space and 100% efficient, which is nothing but I'll explain with the complement terminology, which is C equals to target minus the number. Okay, complement equals to target minus number. Okay, target 6 minus number 3, which is 3. Do we have 3 in the hash table? No. So add 3 and what's the index value? 0. Why are we creating hash table? Just to store the indices. Why do you need to store the indices? Because we have to return indices. Okay? And what's the target value? 6. And what's other number? 2. We got 4 here. Do we have 4 in the hash table? No. Then just add this 2 into our hash table, which is 2 and the index is 1. Target is 6 and the last value is 4. 6 minus 4 is 2. Do we have 2 in our hash table? Yes, we have at index 1. So 2 comma, what's the index value of 4 is 2. That's how we got 4 comma 2. 1 comma 2. Okay? The complexity of big O of complexity is big O of n and space complexity of is big O of n. Now let's look at the clean Java solution. So each line does its own job. We are storing and checking, boom, and done. Interviewers love when you use data structure smartly, which we have done now. Okay, what we are doing? We are creating a hash table like earlier. Okay, here we have created a hash table. So what are the values? 3, 2, and 4. We're gonna do a for loop. So we're gonna take each complement. So the complement equals to what's the target? Target was 6. Target was 6. Target minus what's the number? 3, which is 3. Do we have 3 here? No, we are checking. if the map contains complement 3. Do we have 3? No. No means we will put 3 here. Okay? Again, we will take complement. 6 minus 2, which is 4. Do we have 4 here? Do we have 4 here? No. So we will just add 4 comma 1 because its index value 2 comma 1, sorry. 2 comma 1. 0, 1, 2. 2 comma 1. And we have complement 6 minus 4, which is 2. Do we have 2 in our hash table? Yes. So this is true here. So we're gonna return map.get of complement. Okay, we're gonna return 1. So this is the key value. So 1, comma. What is the I value? Which is 2. 1 comma 2. Okay. If we don't get anything, we will return an empty array. Okay. We return here. Okay, let's run this now. So here is the summary of this, which is like brute force. It is big O of n square. Okay, but hash map we got big O of n. This is the ninja move. And this is the beauty of DSA. Same problem, totally different speed. And that's day 3. Two sum wrapped. Day 4 drops tomorrow. So one problem every day. Let's go till consistency becomes a habit. Thank you.